Yes, welcome students. I am very much happy to see you all of here in this wonderful time. Today we are going to talk about the Boolean algebra. It comes in unit number 4. Unit number 4 consists of Boolean algebra. So in this topic we have some subtopic. What is a Boolean function? Representing Boolean function, logic gates, and minimization of circuits. That's what we are going to discuss today. We know already what is a Boolean algebra, right? A Boolean algebra is nothing but an algebraic structure consists of a set B and with some two operations, meet and join, and corresponding to that we have 0 and 1 and also a complement. And we already know that it is an algebra because it satisfies all the conditions that it should be called algebra. It satisfies commutative property, distributive property, associative property, identity existence, and also complement properties, and also the identity for join, identity for meet. All we have satisfies by this algebra, and that structure we call it as Boolean algebra. Now let me discuss about what is a Boolean function. Suppose x1, x2, x3 xn are n Boolean variables. Okay, and that satisfies the following conditions. These x1, x2, x3, xn n variables, which are Boolean variables, which has satisfied following conditions, then we say that it is a Boolean function. 0 and 1 or Boolean function expression. If x1, x2, x3, xn are Boolean expression, then the meet x1 meet x2, also x1 join x2 are also Boolean expression. I mean, if x1, x2, x3 are all Boolean expression, then the meet between the Boolean expression is again a Boolean expression, or join between the Boolean expression is against Boolean expression. And some other conditions: if x1 is a Boolean expression, then x1 dash, so here some dash, that is complement, is left out. You include this complement here. So if x1 is Boolean expression, its complement is also a Boolean expression. And last point, all framed from above string is also a Boolean expression. Okay, it may satisfy the single conditions, or it may be connected with all the 5 conditions expressed above. Then the expression we call it as Boolean expression, or the string we call it as Boolean expression. We can have a lot of examples for that. Okay, this is a good example because only one Boolean variable is there. That also we can say it is a Boolean expression. It's a Boolean expression. Now let us take the second example, f x1, x2, where x1 and x2 are Boolean variable. Then this is a Boolean expression because it is framed from the rule of law. x2 is a Boolean variable. It is connected by, joined by x1 complement. x1 is Boolean variable, therefore x complement also Boolean variable. When this is joined by x2 is again a Boolean expression. So f x1, x2 is a Boolean expression. The same way, example 3, f x1, x2, where x1, x2 are Boolean variable. Then the right hand side given here, x1 complement joined with x1 inside the bracket, its complement is a Boolean variable because it satisfies the conditions of the Boolean variable. Now look at this, the second bracket. x1 is a Boolean variable, x2 is a Boolean variable. Join these two, again Boolean variable. This bracket meet this bracket is again a Boolean expression. So this is a Boolean expression. So we discussed about what is a Boolean algebra, then what is a Boolean function or Boolean expression. Okay, examples also we have given here. Right, this Boolean expression can be put in different form. We have already studied in our lower classes, I mean in the BSc discrete mathematics class, about PDNF, PCNF. Can you remember those things? PCNF means principal conjunctive normal form. PDNF means principal disjunctive normal form. So the Boolean function is based on Boolean expression writing in the form of sum of products or products of sum. Sum of products, that is meet of sum. Sorry, join of sum. That is called what? Sum of products. Sum means join, products means meet. So sum of products we can say are join of meet. Similarly here, the meet of joins, the meet of join, meet of join. So two expressions or representation of Boolean functions. One is sum of products, or otherwise we can say that join of meets, or other one here meet of join, meet of join. So there are two expressions that we have to understand. Okay, one is sum of products or join of meet, another one is meet of join. Now we will take an example and understand exactly what do we mean by that sum of products or products of sums. If a Boolean can be expressed as sum of min terms products or sum of products, then it is called sum of product form. We must be able to write like this: sum of products, sum of products. See, this is one product. See, meat comes here, or product. This is another meat or product. So this is what sum. So sum of the products form. So this Boolean expression is of the form sum of products, sum of products form, sum of products form. Now let us this also. This is the one product, this is another product, this is another product, because all consist of meats. What we do, we are joining here. Look at that. This product join this product, join this product, or this product sum this product, sum this product, or sum of products, or join of meats, we can say. Okay, the another form just before I was telling you about is product of sum form, product of sum. If a given Boolean can be written as the product of sum or max term sum, then it is called product of sum form, product of sum form. Okay, example is here. See, this is sum, 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 product, product. So product of sums. From outside you have to come inside. You have to, should not start here from inside to outside, but from outside to inside we must say product of sums, product of sums. Similarly here, sum of products, sum of products. But here not like that. Here product of sum, product of sum. So any Boolean expression can be written as product of sum form or sum of product form, product of sum form or sum of product form. Anyway, we can write. So these are expression of the sum of products or products of sum, and this is what? Product of sums, product of sums. This is what? Sum of products, sum of products. Now we'll have one example for that. Okay, now look at this. This is what? A Boolean expression. Am I correct? This is a Boolean expression. x1 meet x2. Can we write this as sum of products? Yes, we can. Now look at this here. X meet x1 meet x2. We can write like this. x1 meet x2 equals x1 star or meet x2 meet. This is 1. Am I correct? The sum of or join of the element or Boolean variable and its complement is 1. Am I correct? So 1 meet this is this. 1 meet this is this. So this can be written. This can be written this form. This can be written in this form without loss of generality of the Boolean algebra. This is 1 meet this. So A meet 1 is A. That we can write like this. Now distributive law I am using here. x1 star x2 star x3, x1 star x2 star x3, and then this is distributed, that is join is distributed here. Okay, so join again, that is this and this and this and this, this and this and this and this. So we have x1 meet x2 meet x3, meet x3. Am I correct? So this at this and at this last one. So x3 dash should come here, I think so. Okay, x3 dash, because this one x1 is here, meet x2 is here, meet x3 dash. x3 dash is there, but it's not seen very clearly because of this bracket. So now what is this form? Sum of products, sum of products form, sum of products. That's what. So given expression can be written as sum of products form, sum of products, or join of meets, join of meets. That way also we can say. One more example we'll take, and with that we have to end today as 15 minutes is over. So let us take this. x1 join x2, x1 join x2. We have to write this as join of meet, join of meet. x1 x1 join x2, x1 join x2. We can write it as x1 meet 1 is x1, this join coming as it is. x2 meet 1 is x2 itself, so x2 we can write it as x2 meet 1, x2 meet 1. Now distributive law we can use here. So x1 meet x2, sorry, we are not using the distributive rule, but we are using this identity rule here. In the place of 1 we can write it as x2 join x2 dash. In the place of 1 we can write like this. From the algebra, Boolean algebra, 1 can be replaced by a single Boolean variable join with its complement. We can, 1 can be written like that. So x1 in the place of 1 I am writing this, so this meet comes as it is, and this in terms of join we can write, because our aim is to write the join of meet, or the sum of products we have to write. That's why we are writing like that. And similar way, x2 as it is, meet as it is, in the place of 1 we can write like this: x1 join x1 dash. This is what the Boolean algebra says, in the place of 1, or x1 join x1 dash equals 1 from Boolean algebra. We can write 1 as x1 join x1 dash. Okay, so in the place of 1 we can write like this. Now we can do the distributive law. X1 meet x2 join x1 meet x2 dash. This join comes here. x2 meet x1. This join comes here. x2 x2 meet x1 dash. Okay, right. Now this is what form, and again we can distribute. At last we have this, right? So x1 meet x2 join x1 meet x2 dash join x2 meet x1 join x1 dash meet x2. Right? Very interesting, huh? Yes. So what is this? Join of meet. That means sum of products. So if any one comes 2 times, we have to write only 1 times. That rule is applied here. Okay. See, look at that here, and here x1 x2 comes here, join comes here, x1 x2 dash comes here, and then here x2. So 2 times x1 meet x2 comes. That only 1 time we are writing. This is writing as it is, and last one is coming over here. So what we understand is that the given expression called Boolean expression, x1 join x2, can be written as the join of meets. We can the join of meets, or we can say sum of products. Sum means join, meet means product. So sum of products we can write. So given expression can be written as sum of products or join of meets. The similar way we can write this like this. Okay, so this is what product of sum, that we can write as product of meet, product of products, that we can write. Okay, so with this problem we are going to stop, and the next class we will be discussing about another problem. With that I come to the end of this class. Thank you my students, very much happy. Thank you.